So we're going to continue our discussion of this big topic of calculus, which is derivatives. All right, and we're going to break it up into smaller pieces again. All right, so in this video, we're going to look at tangent lines and how to kind of create the equation of a tangent line. We've mentioned tangent lines in the last set of videos and in class. So now how can we create these equations? All right, well, the first thing is just a quick review of lines. All right, the most popular form for lines you'll see is slope-intercept form, y equals mx plus b. And most of the times, this is the way we want our final answer, because there's only one way you can write an equation in slope-intercept form. But there's other forms as well. The one that's going to be useful for the kind of start of our problems is this one, which is called point-slope form. So I have the point xy and the slope m, and I can plug them in there. And if I simplify some, I can change it into slope-intercept form. And there's also standard form for lines. This is not really useful at all. Normally we'll change it into slope-intercept form as quickly as we can. All right, so when we're trying to create the equation of a tangent line, all right, we're going to end up using point-slope form. So the first thing we do is figure out the slope, right? Because we're going to need the slope for slope-intercept form. But since we're talking about a tangent line, the slope of the line is the same as the derivative, right? The slope of the tangent line is the derivative. So if I'm figuring out the derivative, I'm also finding the slope of the tangent line at the same time. Okay. And where's my point going to be? Well, a tangent line, if I have a function, the tangent line hits your function at that point. So you're going to use your original function in order to find the x and y value of that line. So you use the derivative to figure out the slope and the original function to figure out the x and y value. All right, so we want to find the slope of the tangent line to y equals x squared at x equals 2. All right, so first let's find the derivative at x equals 2. All right, f prime of 2. All right, remember that means the derivative at 2. Right now we have our limit definition. We have a couple of different definitions, but this is the one I like the most. Of f of 2 plus h minus f of 2 all over h. All right, the first thing is, just for time and how much I have to write, I'm going to kind of skip one step on my right. So I have to plug 2 plus h into there. But remember, that means you have to FOIL it. So that is going to become 4 plus 4h plus h squared. I'm going to subtract when I plug 2 into my function. Well, 2 squared is going to be 4 all over h. And again, the tip that you're doing these correctly is the non-h parts cancel. Which is a good thing, because if everything has an h, I can factor the h out. And then cancel it out with that one on the bottom that's been giving me issues the whole time. And then once you cancel out that one on the bottom, now I can just plug in 0 and get 4. So my derivative at 2 is 4, which means the slope of the tangent line is 4. All right, so this is going to be part of my final answer. All right, the other part of my answer is the x and y value. Well, that's going to use the original one. So my original one is using x equals 2. The y value is when I plug that in, and I get 4. Which this means if the x value is 2 and the y value is 4, that means the point 2, 4 is where that tangent line is going to hit my original function. So now I can plug it all into point-slope form. Y minus the y value equals m times x minus the x value. And that's technically right, but most of the time you simplify into point-slope form. So I distribute first and then add. And this would probably be the most likely answer you would see on the AP exam for the slope of the tangent line of this function at 2. All right, so the derivative, the slope of the tangent line is 4, and we use that other point to get to our equation. All right, now we're going to use this table in order to create the equation for the tangent line at 3. Well, we're going to have to put it in point-slope form. first thing we'll do is find the slope of the tangent line. Well, the slope of the tangent line is represented by f prime, and the x value we care about is 3. So f prime of 3 represents the slope of the tangent line at the x value I care about, so that means I can put a -2 there, because the slope is -2. I also need to know the point from the original function. Well, again, x equals 3 is the one I care about. When I plug in 3 into my function, I get out 6. So that's going to turn my equation into this. And then again, just some simplifying to get it in slope-intercept form. So this one just doesn't have all the expressions. You just kind of know that because your x value is 3, you kind of care about this middle column, because that's when the x value is 3. We use the right-hand column for the slope of the tangent line, and we use the left-hand column for those x and y values.